Right. Good afternoon, everyone. We'll talk today about multiple layer 3 backends in a cloud. So let me start with the quick introduction first. I am Manjeet, and I work for Intel. I'm a cloud software engineer, and I'm a networking ODL core, and I'm also a contributor to OpenStack Neutron project. And I'll pass a mic for a bit to my co-speakers for quick introduction.
Hello, I'm Takashi Yamamoto, working for Midonet and Mirokura. That's all.
Hello, I'm Misaki Yamahata, working for Intel. I've been contributing to OpenStack Neutron and also networking ODL and open daylight integration part.
So we will discuss about how to enable multiple layer 3 backends in the same cloud. What we have on agenda is we will start with the Neutron L3 framework, and we'll also discuss why to use that flavor framework, and we'll also talk about use case, and then we will also showcase the sample driver, and we'll also talk about driver enabling, how to enable that driver backend, and we'll discuss about traffic between different backends, how it is right now, and then we'll move on to data path connectivity among the backends. Then we will also discuss challenges we had faced while developing that driver, and then we'll wrap up with the summary. So starting with the Neutron flavor, so it's like a common framework that allows user to enable multiple layer 3 backends in a same OpenStack deployment. Before I get into details of it, I'd like to talk about how L3 servicing is handled in absence of L3 flavors. So Neutron had a notion of L3 service plugin, which had entry reference implementation for drivers it provide. It had 4 drivers: single node, HA, DVR, and DVR. So in order, if somebody wanted to use a layer 3 backend, they had to replace the service plugin with the monolithic plugin, and the entry, there's something wrong with the display there. Got it. And entry, if somebody had to enable a special backend which suits their routing functionality, they had to replace the service plugin, and which would lock into them. So all the L3 operation has to go through that service plugin. So with the Neutron flavors solves that problem by allowing to have multiple layer 3 backends. As you can see, there will be a router plugin with the callback mechanism. You can have different flavors enabled within the same cloud deployment. So user have to basically define the flavor while creating the L3 resources. So they just specify those flavors using OpenStack CLI or Neutron client, and then they can associate their L3 resources to that particular flavor. So talking about details of how this flavor framework works. So this is the slide. This is the screenshot I got from L3 flavor framework. So whenever somebody sends a request to create a L3 resource, Neutron server hands that request to L3 router service plugin, which do all the create, update, delete for resources, and it also handles the DB transaction, and then passes the control to router driver controller. And then the job of router driver controller is to validate the associated flavor exists and it's loaded properly in the cloud. And then the driver controller will dispatch the request based on the flavor associated to write driver. So with this, you can have like multiple drivers in the same cloud, and so you can use like X driver for subset of routers that suits the functionality or based on tenant requirements, and use other driver for another sets of router. It's very similar to ML2, but there's an important difference. So what happens with ML2 is ML2 allows you to have like different layer 2 backends like Open vSwitch, Linux Bridge, and there is some implementation difference. ML2 will call on all the drivers which are enabled, and all the drivers will be called, and all the requests for layer 2 operations will be handed to all the drivers. But in case of layer 3 flavors framework, only the request will be dispatched to associated driver, and other drivers will not be notified. So with that, I'll pass the mic to Yamamoto. He will discuss about use case and like motivation behind this flavor framework implementation.
Thank you. Thank you, Manjit.
Go ahead.
Can you move to the next page? Thank you. Let me talk about use cases. We started from a very simple use case, that is having multiple backends in a single Neutron. You know, two backends have their own logical topology, and they are completely separated each other, so no traffic between them. Where it is limited, it can be used for example, if you want to make your cloud migrate from a backend to another in an incremental manner. Can you move to the next page? Thank you. Besides use cases, we have another motivation, that is simplification of code. Some parts of L2 plugin methods, say a part of create port, should be executed without holding a DB transaction, because it might perform remote calls to the backend, which can take very long, and it isn't desirable to keep DB transactions that long. On the other hand, L3 plugin has its own DB transactions, and it's often convenient to call L3 plugin with the transaction held. So historically, L3 plugins used to call L2 plugin with or without a transaction inconsistently. In the previous cycles, we refactored the reference L3 plugin so that we can avoid the transaction issues. So, of course, vendors can improve their monolithic L3 plugins by themselves, but it would be nice for vendors if they can just use the same reference implementation. Next page, please. Now let me explain how to configure and use vendor L3 flavors. In order to use vendor L3 flavor, you should configure Neutron configuration file in Neutron conf. You should specify router that is the reference L3 plugin as your L3 service plugin. Besides that, you should configure your L3 flavor driver. It's specific to your backend as an service provider of L3 router NAT type. And when creating your router, your Neutron router, you should specify your flavor. Beforehand, you should prepare your flavor and its profile. First, you should create a flavor profile and a flavor and bind them together. Sorry. Then, as a last step, when creating a router, you can specify the flavor. In this example, it's ODL. Now let me pass the mic to Isaac.
Okay, thank you, Yamamoto. Yeah, now from now on, yeah, let us share our experience in our journey for L3 flavor. So yeah, this screen shows sample code. Actually, this is the implementation of OpenDaylight L3 driver. But yeah, you can read it. But anyway, yeah, unless you are actual backend implementator, you don't have to read it. So if you are implementator, yeah, you need to look at other OpenDaylight backend or Midnight backend. Basically, so far, as before, we needed to implement monolithic L3 plugin. But now we have well-defined callbacks. So we need to implement each callback and to do we need to implement what's needed for its own backend. And then, yeah, this slide shows actual callbacks. Basically, it's quite similar to ML2 interface. It has a pre-commit callback and post-commit callback, basically. Then for each resources, in this case, router and floating IPs. So let us share, after we have implemented, we have a question about do we like to have east-west traffic between different backends? And technically, we can address it, and we can think of several ways to address it. But it may require quite effort to do this. But so far, we don't have requirements for this. So for now, we don't think it's worthwhile to address this. Please remember from the use case, Yamamoto explained the actual use case. The use case is backend migration from one backend to another backend with single Neutron deployment. So right now, we don't see requirement for east-west traffic between different backends. If you have clear requirement for this, please voice it. Then, we have a justification for it, so we can address it jointly in the community. And also, right now, our answer is it's not worthwhile. So simply, we don't allow east-west traffic between different backends. But another way is to use, for example, legacy or reference implementation L3 implementation as a sort of common traffic way. And also, yeah, we can think of various possibilities. But yeah, so far, we don't think it's worthwhile to address it. Oh, and yeah, this slide with this slide, we'd like to share our experience. Yeah, so in the process of implementing L3 flavor, yeah, we hit sort of a complex interaction between plugin and callbacks. And so far, yeah, so finally, yeah, we ended up to enhance Neutron callback systems to add priority to guarantee the order of callbacks. So yeah, at first, yeah, we didn't expect it, but yeah, finally, yeah, we ended up a clean solution with a collaboration with the community. And so that's the most significant challenges. And another issue is we have, the task is not done yet, so we have several not minor, relatively minor issues. One is the floating IP compatibility. The way to implement floating IP is to use Neutron port, but to associate that port to actual backend ML2 mechanism driver. So yeah, L3 flavor backend flavor driver is not typically L3 flavor driver is compatible with its own ML2 mechanism driver. So we'd like to ensure user is using consistently, and we'd like to give error when user uses it wrongly. Right now, yeah, our instruction is you do it correct, and if you do it wrong, you'll get trouble. And right now, yeah, we are trying to do more tests. Right now, actually, we are trying to establish Tempest shared job with OpenDaylight, and I think yeah, Midonet will also follow it. And also, yeah, typically, last one is the tenant associated to L3 flavor. Please remember, the use case is backend migration. So typically, cloud admin doesn't want allow actual cloud user to specify its L3 backend. New user will just use new backend, and all the existing user continues to old backend, and then yeah, gradually migrate to new backend. So we like to so cloud admin doesn't want user to specify it, just automatically flavor driver is chosen for user. So such part is right now is missing. Okay, so far, yeah, in Rocky cycle, yeah, we have mostly done of L3 flavor, and we have mostly done L3 flavor drivers for OpenDaylight and Midonet. And actually, some patches are still in underlay view. So yeah, so we'd like to call for action to try test and use it and give us feedback. And then, yeah, if you are a backend implementator, so please go for L3 flavor driver instead of your monolithic L3 plugin. Okay, here is the related patches. Right now, they are under review. So we hope to merge those patches for Rocky cycle. But yeah, we will see. Okay, thank you for listening.
Now we will open up for questions. If you have any questions, please ask.
You're saying that as an operator, you couldn't determine what flavor a user got when they created a router. Is that right? When you said, there's a couple of slides back, you were saying maybe, yeah, so, you know, new tenants use one backend, existing tenant. So is there, if a if I create a router and I don't pass in a flavor, what happens?
So default one is chosen.
That's what, sorry?
Yeah.
So,
Yeah,
default?
let's see.
Okay, yeah.
Yeah, default. But we'd like to make it default per tenant,
Okay, yeah, yeah.
per user.
okay, so I think I can add it to it. So when user doesn't specify any flavor and the flavor framework is implemented, then the driver controller will fall back to based on other parameters. Like if you specify HA or DVR, there are like 4 entry Neutron drivers. So Neutron driver controller will fall back to entry implementation and use those drivers to provide you L3 router.
Okay.
Yeah.
Any other questions or comments? Okay, yeah, we are done. Thank you for coming.
Thank you.
Thanks.
Thank you.